There we go. Yes, it is. It is great, and it's very exciting to be back at Angular Connect. And today I want to share with you a practical guide to reducing your bundle size. So we're going to dive deep into some things. We're going to look at some other higher level concepts, but hopefully you'll come away from this talk with some ideas to take back if that is true that you want to reduce your bundle size. And hopefully you won't be left with a feeling like this. So if you look at these two circles, which of the orange ones is bigger? I mean, it sounds like you've all seen this before. But yes, you're right. I heard someone say it. They are exactly the same size. And this isn't what I want you to take away from the talk, that you'll go back to your offices and work and you'll have these tips, and then at the end of it, your bundle size is exactly the same. That's not what we want. We want things to get better. So I guess a little bit of background about who I am. I was in the financial industry for 10 years before moving over to AG Grid. I actually first saw AG Grid at Angular Connect. I've got one wife. I don't know if I need to clarify. I've got one wife, 4 children, and 2 dogs, Rufus and Coco. This was my talk back in 2019 on NG Template Outlet, so you might know me from that too. But what I'm currently working on is AG Grid and AG Charts. So hopefully you've heard about us. You might have heard about AG Grid quite a lot. Maybe you haven't heard about AG Charts so much because this is a new project or new product that we've launched maybe last year, which is bringing all the expertise we've had with AG Grid and applying that to charts. So these are both completely standalone components that you can use in your Angular applications if you need to display lots of data or if you want to start using charts. And these integrate really nicely together. So if you want to take a look at this or have more questions for us, do come and find us at the booth. Right, let's dive in. I mean, first of all, maybe I have to try and convince you, hopefully not, like why do we want to reduce our bundle size? And hopefully we're all on the same page in terms of our bundle size is how much JavaScript we ship to the user. So faster load times, it's going to be quicker to download. Not all of our users do have fast internet connections. You're going to have an improved user experience if there's less JavaScript to parse on their machine. Again, not everyone has super fast laptops. And hopefully this will have a positive impact on your SEO. And so this is something which our clients wanted from us with AG Grid. And so we did a lot of work on this, and that's where some of the knowledge and things that I found out has come from. So version 33, we managed to get our bundle size down by about 40% for the simplest use cases. And that was through tree shaking and also improving the minification. So we'll talk about both of these aspects. So first of all, let's have a look at tree shaking. So the term tree shaking kind of wasn't around until about 2015, where Rich Harris, the creator of Svelte and also Rollup, came up with this idea of rather than excluding dead code, we're going to include the live code. So we start at our entry point and we see, following this abstract syntax tree, what does the code need? And I'm going to keep all the things that it imports and touches. And that's going to be what ends up in our bundle. So for example, say we've got this utils file, we've got a sum and a multiply, but in our main function, or in our main file, all we're doing is we're using the sum. So here we can see, well, we're not using the multiply function, so there's no need for us to ship that to the end user. So we're going to drop that, so when your code is compiled, that doesn't end up in your final bundle. So we've shaken that tree, that part of the tree away because it wasn't used. But an important thing to realize straight away when we start dropping code is, does the code that we're dropping have any side effects? So a side effect is code that performs some external change when that module is loaded. So let's have a look at an example. Say our utils function, this is quite contrived, has this console log at the bottom of it. So this is going to be a side effect because it's going to cause an externally visible change when we load this utils module. So if we use this sum function, what you're going to see in the console is, this is a side effect followed by the sum. If we then updated our code, where we didn't actually use the sum function, we just logged the answer directly, and then our bundler removed that unused import, what we have now is a different result. So the thing to be aware of here is we have to be careful, or the bundler has to be careful and know that the code it's going to drop hasn't got some side effect, because otherwise it could be potentially broken. So when is it safe to drop code? First of all, there have to be no side effects in it. And this is quite hard for the bundler to always know. So it can either try and work out if there are side effects, and this can be quite hard and quite slow. It can either go, well, I'm going to assume everything has side effects unless I'm told otherwise, but that reduces the amount of code that you are actually going to be able to tree shake out, because it might think, well, I don't know if I can remove that, so I'm going to leave it. Or it takes lots of manual annotations from the author to say, well, this is safe, this isn't. So this is something which you maybe use more as if you're developing a library, as opposed to in the application itself. But you might see, when you've been looking at some of the libraries that you might want to use, that they have this flag in them, side effects false. So what this is saying is all the code is side effect free. So if nothing is being used from a file or that import, that can all be tree shaken away. It's also possible to provide globs for this. So you might want to say, well, don't take away the CSS files or the polyfills. Nothing is going to directly reference them, but because they've got side effects in them, don't drop them. Another way that this is kind of hopefully more of a last resort if you run into this case is that sometimes you can have these top-level functions in a module which they're complicated, but they are pure. And so you can use this annotation pure, which then tells a lot of the bundlers that actually this is a pure function, there's no side effects in it. So if it's not used, you can remove it. So this is definitely less common, or we wouldn't expect you to have to use it so much. But it's a good thing to be aware of if you do run into cases where you're expecting something to be dropped, but it isn't. But I think before you get to that stage, there's some inbuilt tools that Angular gives you out the box, which you should definitely be using. So like you've got your lazy loaded routes and you've got the defer block. These are really powerful ways that Angular makes it very easy for you to split your code up yourself. So make sure you're using these. I'm not going to spend too much time on it because hopefully this is well ingrained in the ecosystem and in all your applications already, so that when you go to one route, you only load the code that you need. And again, hopefully the defer block should be used if you can have a big, large component. This is a great way of then just offloading that work and saying, well, when you come to this page, set up the right handler to then load it, I guess, on demand or whenever your triggers are. But that's all I'm going to say for those, because I want to go a little bit deeper. So there's a few ways you can break tree shaking, and decorators are actually a very good way of doing this. So this simple code came from AG Grid in version 32 and all the previous versions, where we use these beans and auto-ring as a very nice developer experience for us creating the grid. But the downside of using them is that they got compiled into code that looked like this. And the key thing is the decorators would always have a static reference or a reference to the class, which meant as soon as this module was loaded, the bundler thought all of this code was always used, and so it could not be tree shaken. So in AG Grid, you maybe have seen like all the different modules and npm packages. That was our way of tree shaking. If you didn't include the npm package, then you wouldn't have the code. Whereas now that we've made all these changes and got rid of our use of decorators, we can put all of our feature modules in one npm package. It's simplifying all of your code, but still achieving good tree shaking. So this was a big effort on our part, but something that we feel has really paid off. So now we define our code with these different modules and features so that when we add new things, we're not going to increase the size of everyone's application if they're not using them. And maybe some of you are saying, but Angular uses decorators. So yes, you might use decorators, but Angular internally, I don't know what the right word is, but strips them, and so that they don't actually cause these same issues. So don't be fooled by the magic that's happening underneath the hood. Another thing to watch out for is barrel exports. So say you've got lots of utils files and you will then group them all together and re-export them from the barrel file. Say you're only going to use the sum function. So if you're in your main file, you do utils underscore and then .sum. We can't shake away everything else because they're all attached to that utils object. So a simple change, just import the ones that you need from where you need it without the barrel file, and then you can tree shake away the rest. And I think this is where, once you go down this path, you'll realize tree shaking is very easy to break. The different build tools have different mechanisms of how they work out what they can tree shake. So we had these modules, and all of them were repeating like how you're setting the name and the version. So we thought, well, let's just create a shared function so we only have to set the version in one place. We applied that, and suddenly in our tests, everything that was building with ESBuild, tree shaking stopped working, whereas Webpack was fine. So you've got to be careful when you're doing this, which leads me on to my next slide, that testing is key. And at least Angular makes this very easy out the box. So when you create a new project, you'll get the budgets in your configuration. Hopefully, you've all actually set them and haven't left them on the defaults. So, and you've got different ways, different types. You can say the initial one, so that's for just the code that is on the initial render. Any script, you can set a limit on that, or any component style. So definitely have a look at these size budgets and make sure you're using them appropriately. Or you can use an external package like size limit, so that can run on your GitHub action and give you, I guess, a status on your branch so that you're aware of when changes are happening. Because this then gives you the visibility to go, actually, I need to see what I've changed and work out why that's broken the tree shaking. So your test has failed. Now what are you going to do? So hopefully you've used this tool, Source Map Explorer. Make sure you're building with source maps, otherwise you're going to miss out on a lot of the information. So this gives you this overall picture where you can then dive into and see, okay, what is contributing to the size of my bundle? Even before your test has failed, this is a really revealing way to see, okay, what parts of my application are actually the biggest and where should I start looking if I want to reduce it. There's also another version of this kind of tool called Sonder, which is a Veep plugin, and that has Angular support as well. And what you can do with this demo is you can dive down into each of these individual sections of an application, and it'll give you information about it, as well as then giving you the opportunity to see, okay, which of the code from this file is used or which code isn't, which again is just giving you more insights into the structure of your code and opportunities for improvement. And there's another way which I found quite useful and quite a nice way of doing this, is just manual file inspection. So open up the dist folder and just see what's in that file. There's a build flag that you can say ng build mangled to 0, and that might help you actually see the code and understand what the code is. So instead of it being minified, you'll get like class names, and so this will help you identify actually in the file which you're going to ship what code is there. Because sometimes the best thing to do is just look at that file, read through it, get used to the way it's moving code around, and see the differences when you apply different changes. Which kind of leads me on to, well, maybe once we've done the tree shaking, or we can't really make any more improvements there, we need to look at our code and go, well, is the way that I've written this code helpful for minification, or are there ways that I can optimize it? So minification is this process of removing unnecessary characters. So, the variable names, they don't need to be so long. We can shorten, we can get rid of the comment. So the minification of this function is as like 25% of the size at the end. You can't change the function name in this case because it might be referenced somewhere externally. But how do we optimize this, or what doesn't minify? So class properties are an interesting case. And it's worth noting that, like, so you give yourself you've got rows and columns in here on your grid class. And the rows is private, columns is public. So the columns can be, updated externally, but for the rows, they're not. Does that, oh, I've got some bad code there, haven't I? I'm accessing a private variable outside. I'll have to fix the code there. But I think it kind of proves the point. Maybe that's what I'm trying to show. If you'd stuck a cast, an any in here, that private property is still there. I think that is what I'm trying to show. So TypeScript says it's private, but in JavaScript, it's not actually private. So if our bundler came along and we were trying to mangle these properties, so we've got this, our grid class with the rows, which now isn't marked private. And we've got this function called add to grid row, where we're pushing rows into that grid. If the bundler then mangled the property rows down to R, if it wasn't able to find every single place that code or that property is used, then the mangling process would break our code, because then it would be trying to access that property via a different name. So they can't be mangled, and so the bundlers don't mangle it. And so if you've got all these names in there, it's an opportunity for minification to be better. But then the key thing is, what if we knew they weren't accessed outside the class? And this leads us on to true private properties. So this syntax hash and then the property of the name is a truly private variable from JavaScript's point of view. So if you instead had a class where the rows were now using this syntax, you can't access it outside of the class. So the bundler can now take advantage of that information and say, well, it's definitely safe for me to mangle this property because I only need to do it within this file. And it can be confident that it isn't going to be breaking any other code in the process. But you need to be beware of downleveling. So private variables, this is supported in ES2022. If your code is using them and then being downleveled to ES2020, it's going to have to polyfill them. And not only is this code less performant, it's also actually going to result in a bigger bundle size. So you're actually going to be working against yourself. So make sure you're targeting ES2022 at least. And not just that, you have to check your browser list as well. So that Safari 16 had issues with this. So the kind of key takeaway is version 19 plus, you're good to go, based on the browsers that it's targeting and the version that is output. So you might see some benefits. You can probably even use AI to help you with that migration. There we go, I've said AI. So, and then this part is just some quick fire optimizations, which some of these you may think is going too far. Some of them I think is going too far, but I thought I would let you know anyway for you to make that decision. I think this one's quite a safe one. Say you've got all this logging and extra information about error cases. So we had this, so if people make a configuration error in AGGrid, we want to help them in the console, but then we don't want to ship all that code to their end clients because it shouldn't be needed. So instead, we just throw error codes. And if they provide the validation module when they're developing, then they'll get the full text. Otherwise, they just get a nice link and they can go and view the context on our website. But we've cut out a lot of code. If you're writing code in this way, where you're accessing a variable from the class repeatedly, this code isn't going to minify as well as, say, you pass in the CSS class manager, because then that can all be mangled very safely down to this, and you can reduce some of that duplication. But what you might see is that we're actually going to have this string add CSS class repeated lots of times as well. So this kind of leads on to the next one, where maybe we can invert some of these functions. So this is another example where in this grid option service, we've got this method saying add grid API. And instead of that being called, you'd have gros.addGridAPI and have that all over the place. If you flip this method so that it becomes a standalone function which gets this grid option service passed into it, you can then have that mangled down to a single letter for that method and have that repeated everywhere. And you'll only have the string addGridAPI in one place. So again, when you get to this point, you're really trying to push your bundle size down with quite a lot of effort. This one's controversial. So say you've got some nicely named temporary variables, like here we're pulling out this variable, assigning it, and then passing it through to another method. We could just directly inline that, and 15% smaller for this method once minified. But you're going to start getting into battles of, is this code less readable, and is it going to get past someone's review? So yeah, I don't know, but it's there. And yes, it can be very tedious. So go as far as you need to go. Go for the easy wins. For a library like us, it's valuable for us to keep pushing further than you might want to do in your application, because where our library is used everywhere and people are depending on us, then it's worth our investment to go. So go as far as you want. It's up to you. But then also be aware that there's quite big variations in build tools. So we often focus on the speed differences with the build tools that we're using. But we don't maybe consider, well, there's actually differences in the output of their size. So there's an interesting article here about actually documenting this and comparing different build tools across popular libraries and frameworks and saying, well, this is actually the difference that they achieve in terms of speed and size. Which kind of brings me onto the Angular build tools that we get. So what we found is ESBuild, it's faster, but can actually end up in a larger bundle size. And Webpack, it might be slower, but smaller. But as we've just heard in the previous talk, maybe RSPack can actually give us the best of both worlds. We'll see. I haven't tried that out. I've only just added that now. So that's all I've got to share with you this time. So hopefully you won't leave me like that illusion and you will actually go and shrink your applications. Thank you.
Thank you very